LM, token, context, prompt, function calling, MCP, agent, skill. You've spent months trying to understand these concepts, and I'm about to tell you something that might surprise you. They're all the same thing. An LLM can only do one thing: output text. It can't browse the web, it can't query a database, it can't control your computer. It can do absolutely nothing except produce a string of characters. So how did it become an agent? How can it write code, check the weather, or control a browser? It can't. The program around it does all of that. The program reads the text the LLM outputs, takes action on its behalf, and feeds the result back. That's it. That's the whole trick. Today, I'm going to peel back every layer from the bottom up. And by the end, you won't just understand these concepts. You'll have a mental model that lets you see through any new buzzword, no matter how fancy the packaging. At its core, a large language model is just a word prediction machine. You give it the capital of France is. It predicts the most likely next word, Paris. Then it takes Paris, appends it to the input, and predicts again. Maybe a comma, then which, then is, and on until it decides the sentence is done and outputs a stop token. That's it. No thinking, no understanding, no consciousness. Just one thing. Given the text so far, predict the next word. But here's the catch. The model's internals are pure matrix math. It only understands numbers, not text. So there's a translator in between, the tokenizer. On the way in, it chops your text into small chunks called tokens and maps each one to a number. On the way out, the model spits out a number and the tokenizer converts it back to a word. Here's the counterintuitive part. A token is not the same as a word. Helpful gets split into help and full. 2 tokens. Unbelievable becomes unbelief and able. 3 tokens. Just remember this. Tokens are the atoms of the LLM world. Everything goes in as tokens. Everything comes out as tokens. Okay, so the LLM can play word chain, but it has a fatal flaw. The LLM has no memory. This isn't a metaphor. It's literally a math function. Input in, output out, done. The next time you call it, it knows nothing about the previous call. So, why does it seem like it remembers your earlier messages? Because every time you send a message, the program behind the scenes quietly stitches your entire conversation history together and sends it all at once. The LLM doesn't see your new question. It sees the full conversation from the very first message, plus your new question. It hasn't remembered anything. It rereads everything from scratch, every single time. This bundle of everything the LLM sees at once is called context. Your question, chat history, system instructions, available tools, all crammed in together. Context has a size limit called the context window. Think of it as a desk. The desk is only so big. Today's leading models can fit about 1 million tokens on that desk, roughly 750,000 English words. But even with a big desk, if you have a 1,000-page product manual, dumping the whole thing isn't practical. The fix: only put the relevant pages on the desk, search the manual, find the matching chunks, and feed only those. That's RAG, Retrieval Augmented Generation. Don't dump everything. Pick what matters. The word prompt gets mystified a lot. Prompt engineering, prompt mastery, don't overthink it. A prompt is what you say to the LLM. Every message you type in that chat box is a prompt, but there are actually 2 kinds. User prompt, what you type. write me a sorting algorithm in Python. System prompt, rules the developer sets behind the scenes. Something like, you are a senior Python engineer, keep answers concise. You never see this, but the LLM reads it before every response. The system prompt sets who you are and what your rules are. The user prompt sets what you need to do right now. So now the LLM can predict words, see conversation history, and follow instructions. But it's still just outputting text. What comes next is the most important part of this video. If you remember only one thing, remember this. Let's come back to the fundamental fact. A narrow LLM can only output text. It can't browse the internet. It can't check the weather. It can't call any API. The only thing it can do is produce a string of characters. So how does it check the weather? It doesn't. The program does. Let me walk you through the real flow, all 10 steps. Step 1. You ask the program, what's the weather in Tokyo? Note, you're talking to the program, not the LLM. Step 2. The program assembles the context. It packs together the system prompt, the tool list, your question, and any conversation history, all into one big bundle. Step 3. The program sends this entire context to the LLM. The LLM receives it. Step 4. The LLM analyzes the context and outputs a piece of JSON text to get weather, args, city, Tokyo, full stop. The LLM's job is done here. It just produced a text. It didn't call anything. It didn't reach out to any server. Step 5. The program reads that JSON. It parses the tool name, looks up the matching function, extracts the arguments, and calls the function. The program does this, not the LLM. Step 6. The program sends the function call to the external API. The API does the actual work. Step 7. The API returns the result, cloudy, 18 degrees, back to the program. Step 8. The program takes this result, packs it back into the context, and sends it to the LLM again. This is the program relaying information. Step 9. The LLM sees the weather data and outputs a human-readable answer. It's cloudy in Tokyo, around 18 degrees. Step 10. The program forwards this answer back to you, and that's what you see on your screen. Let me see the key part again. The LLM did not call anything. It output a JSON in step 4, and it output a human sentence in step 9. That's all it did. 2 pieces of text. The program did everything else: assembling, parsing, calling, relaying, forwarding. I'll sum this up in 4 words. LLM talks, program walks. The LLM only talks, the program walks. The LLM can't take a single step on its own. Remember that phrase. Everything that comes next, MCP agent skill, is built on top of this loop. The architecture changes, the loop doesn't. We've got LLM talks, program walks, but there's a practical problem. How does the program know what tools are available, what each tool does, what parameters it needs? Imagine you're a new employee with dozens of internal systems. Nobody gives you a tool directory. MCP is that directory in a standard format. An MCP server is a small standalone program that provides 2 things. First, a catalog. You ask it, what tools do you have? And it returns a full list. Each tool's name, description, parameters, and return format. Second, execution. You hand it the LLM's request, and it runs it, returning the result. Before MCP, every platform had its own way of connecting tools. Build for ChatGPT, rewrite for Claude, rewrite for Gemini. The same tool 3 times. MCP unified this. Build once, run everywhere. Think USB-C. one cable works for everything. MCP is USB-C for AI tools. In the function calling example, the LLM talked once and the program walked once. One round trip, but real-world problems aren't that simple. What's the weather here? If it's raining, find me a nearby umbrella shop. That's multiple steps. The LLM says I need the location tool. Program executes, returns coordinates. LLM says check weather at these coordinates. Program executes, returns rainy. LLM says search nearby umbrella shops. Program executes, returns the results. LLM combines everything and outputs the final answer. Every step is the same loop. Talks, walks, feedback, talks again, walks again. A system that can plan autonomously, execute across multiple steps, and loop until completion. That's an agent. This is why Cloud Code, Cursor, and GitHub Copilot all call themselves agents. Under the hood, they're all running the same loop. But here's the key insight. Getting the location, checking the weather, searching for shops. The program does all of that. None of it requires intelligence. The LLM's only job is deciding what to do next. An intelligent agent is actually assembled from parts that require zero intelligence. The agent can plan on its own, but it doesn't know your rules. Say your team has a deployment checklist. Every deploy must pass all tests, verify environment variables, confirm the rollback plan, and notify the on-call engineer. You want the agent to follow this process every single time. Are you going to type all of that out every time you deploy? A skill is those rules written into a document, stored in a fixed location, ready for the agent to consult whenever it needs to. It's literally a markdown file. Name, description, steps, roles, format, examples. Let's be honest, a skill is just a prompt that lives in a different place and has a fancier name. But skills do have one clever design. Progressive disclosure. Level 1. When the agent starts, it only scans the names and descriptions of all skills, like a table of contents. Level 2. When it finds a match, only then does it load the full instructions, like opening the relevant chapter. Level 3. If those instructions reference all the documents or scripts, those get loaded only when needed, like checking a footnote. It's a trade-off between token cost and information completeness. Just enough is optimal. Let's zoom out and see the whole stack. LLM, a genius that can only output text. Token, the atomic unit. Context, everything it can see at once. Prompt, your instructions. Function, calling. It says I want X, the program does X. MCP, the tool catalog. Agent, the talks and walks, loop on repeat. Skill, pre-written rules loaded on demand. From top to bottom, the LLM does one thing. Output text. Function, calling. The program turns its text into action. MCP, provides the tool catalog. Agent, lets the loop run multiple rounds. Skill, pre-written rules that guide how the LLM talks. RAG, picks relevant information for the desk. Memory, stitches history back in. None of these capabilities belong to the LLM itself. They're all granted by external programs. The LLM's sole contribution, outputting the red text at the rate 10. LLM talks, program walks. That loop is how the entire AI world runs. Next time someone throws a new concept at you, multi-agent, agentic RAG, orchestration framework, or whatever gets invented tomorrow, you only need to ask two questions. 1. What text did LLM output? 2. Who read that text and turned it into an actual action? Answer those 2 questions and any concept becomes transparent. I'm Harrison. We only talk about what's essential. See you next time.